Hello everyone, my name is Hunter Caskey and this is the video demonstration of my completed temperature sensor system for software development for real-time embedded systems. As for hardware, I'm using an Arduino Mega 2560, as you can see right here. I chose this over the Uno because it has a larger EEPROM memory, which is where I'm storing all of my temperature samples. I'm using the Arduino to control the three main circuitry components that I have on my breadboard. Those are a TMP36 temperature sensor for sampling environmental temperature. I have a little push button right here, and that's for switching between the two system states that I have, that being data collection and then data transmission. And then over here, I have an onboard LCD that will output information pertaining to whatever state the controller is currently in. My design was a round robin with interrupt architecture, and in this system I basically have two interrupts. One is the falling edge detection on the push button and the timer interrupt that triggers every second. That's done through some software configuration in the Pi, but it controls timer 1 that's on board the Arduino. The logic for responding to these events is all controlled via software that's developed in the Arduino Sketch IDE. Okay, I plugged the system into a battery. I had a battery connection just so it's a little bit easier to gather temperature from the refrigerator. But you can see the elapsed time is ticking and it transmits all of the samples that I have stored in EEPROM every 10 seconds. So on system power up, it starts up in the transmission state, which is what you can see based on the LCD output right here. And it's just pumping out all of the values that were written to non-volatile memory on the previous run when it was doing temperature collection. So for simplicity's sake, I just made it so that you could perform a main action every 10 seconds in both of the states. So 10 seconds for sampling and then 10 seconds for transmitting the data. So now if I actually push on the push button, it'll switch states immediately and then go into collecting temperature. So here you can see it has an environmental temperature in Celsius, Fahrenheit, the voltage that's being read off of the sensor before doing a conversion, how many samples have been taken in the current run of the system state, and the total elapsed time that has been in the state. And this collects every 10 seconds. So I actually can hold the temperature sensor in between my fingers for a little bit so you can see the environmental temperature rising because of my body temperature. So in just a moment it will go up. There you see, I had a little bit of a bump there. So now the interesting part is that I disconnected the battery and I plugged in the serial transmission line to my PC. So the system immediately comes up in the transmission state, and it kind of just waits every 10 seconds and then it transmits the 1 through 5 samples that we had just previously collected now. And as you can see here, in just a moment it'll pop up on the serial monitor all of the data samples. So that's the time, elapsed time in the state, followed by Celsius temperature, followed by Fahrenheit temperature. And that's everything I wanted to demonstrate for the temperature sensor system. So thanks for watching.